to the in which we will be discussing some more important questions and very important concepts of classical mechanics. So I hope that whatever we will be discussing in today's session will get clear to every one of you and will be helping you to make a good command on all these important questions and the concepts which we will be considering here in the session. Even all other important related questions and the concepts with the topics which we will be considering here in the session will be getting clear to you, so you will be able to solve any such type of questions easily in very less time after attending this session. So guys, we will soon be starting the session now and we will be starting the discussion about all these important questions and the concepts which we will cover up in this session today. So if I'm going to talk about the first important thing, let me just check like whether everything is all right and clear your side or not. I think it's okay. Done. So we can continue the discussion now. I hope you all know about the Unacademy Plus and the Iconic subscription. And guys, if you want to join and attend the live classes of well-structured and well-planned courses by the top educators we are having on Unacademy for your upcoming CSIR NET and the GATE physics exam preparation, then you can take the Unacademy Plus or the Iconic subscription. Also guys, whenever you will proceed further to take the subscription, you can use and apply the referral code which is Anjali Live as mentioned here on the screen. You can write all the alphabets in the capital letter, just apply the referral code. At the same time, you will be getting the 10% discount in the total subscription amount. The features of the Plus and the Iconic subscription have been shown here on the screen right now. So I hope if you are gonna just observe this slide, everything will get clear to you. Next thing is that now free unit wise PYQ tests are available on the learning app, so you can check them out as well for different streams. As you can see, for life science, chemical science, mathematical science and for physical science, the free unit wise PYQs are available on the learning app now. This is about the UA Lite, the new feature we are gonna have, and you can also take the 1 month or the 2 month subscription as per this UA Lite for CSIR UGC NET, and the access you will be getting to these different things, okay, curated test series, then question bank, exams of previous year question papers. So this is how you will be able to check out these things if you will be taking these subscriptions, okay, or any of these subscriptions. So this was something important related to the Unacademy subscription guys, and as in upcoming days many new courses by the top educators will be starting on Unacademy. So if you don't want to miss these important courses and the classes by the top educators, then you can take the subscription, and whenever you will be taking the subscription, you can use and apply the referral code that's Anjali Live as mentioned here on the screen. By using and by applying this referral code, you will be able to get the 10% discount in the total subscription amount. So this is how guys everything will be helping you a lot to do the best preparation for the upcoming exam and even to get ready for the upcoming exam. I hope each and everything is clear to all of you now, and we are going to start the discussion about the most important questions and the concepts in this session today. So the first topic, because if you will check out my previous session on classical mechanics which I have conducted just in few days back, on Friday we had that session. So in that session I have talked about many important concepts, points related to Lagrangian, related to Hamiltonian, related to the relation which relates both of them, okay. So this is how we have considered all these important relations and the formulae there, even the tricks have been discussed in that session. Now we will be continuing the discussion here in this session. In this session I'll be taking important questions, concepts, tricks and many important points we will cover up. So these all important points will be surely helping you to solve the questions quickly, easily and in less time. So you just need to do one thing, you need to attend the session till the end and you will be able to master all these points, the questions, concepts, tricks and all these things you will get to know if you will be attending the session till the end. So now let's start the discussion and let's talk about all these important topics, concepts and points one by one. So let's start the discussion about the first one right now, which is phase space trajectory. Okay, now what are the points you need to know if you want to master this topic? Clear? What is the phase space trajectory and how you can easily draw the phase space trajectory if you are solving any such type of question. If right now you are going to feel like, oh, I don't know about it, how to draw the trajectory, or I don't know about it, that what are the steps I need to take. So in that case, don't worry, because after you are going to know about just few points here in the session, you will feel more confident about this topic, and anytime if you have to solve any such type of question, you will not have to worry about it. You will simply be able to solve any such type of question, and you will even be able to tell others about this topic. Done. So let's talk about it. There are different type of questions from the phase space trajectory part we can expect in the exam. What are these different type of questions? Firstly, we need to understand that the first type of question you can have is in which they will give you the potential expression as a function of x. So v as a function of x is given to you. Now you want to draw the phase space trajectory. That's the one kind or type of question. But there is also one more type of question in which the statement or the situation will be given, okay, about the system, and by understanding that what kind of system it is and what is actually given there, okay, Aditya, it will be helpful for M.Sc Physics as well as for the CSIR NET and GATE Physics exam, and even other similar exams preparation. If you are doing any of the other similar exam preparation, it will be helpful for you. So in that case, what will happen when the statement is given? That's the one type of question. They will be telling you about the situation with the help of a statement. Another thing is the potential is given to you. Now you need to draw the trajectory. Now what actually is the trajectory? Let's talk about that. The trajectory is actually the momentum versus x graph. Mostly on the y-axis we show the momentum, and on the x-axis we keep the x itself, okay? So in this case, what's gonna happen? In this case, there are two type of questions I have told you. Firstly, I'll be talking about this one, that if the potential is given, then what you will be doing, and after that I will explain that if the statement or the situation in the form of a statement is given, then what you have to do, okay? So firstly, let's talk about the potential part. If I'm going to talk about the potential, in that case, what will happen? The first thing you have to do is to draw the v versus x graph. Yes, your target is to draw the momentum versus position graph to draw or to get the final trajectory, but to reach to that final step, you have to take this as your first step if the potential is given to you. That is, draw the v versus x graph. It's needed. Okay, after you will be drawing that v versus x graph, now what is the process you have to follow to draw the v versus x graph? If any time your equation or the expression for v is given to you in such a way that it is matching with the standard form of the equation, for example y is equal to mx plus c for the straight line, or it's matching with any of the other standard forms, okay, then in that case you will be drawing the trajectory or the v versus x graph on your own, depending on the dependency which they have given you for v on x. If you are familiar with that kind of graph, you can directly draw it. But there can be situations when it's not possible for you to draw it directly. Then what you have to do? Let me just quickly tell you about the steps, that what are the steps you have to take, okay, and how you will be solving it. So basically guys, the first thing you will do is to equate the given potential with 0 and get the values of x where the potential will be 0. At the same time, if we are going to talk about the next thing, that's going to be that you have to find the dv upon dx and equate it with 0. Once again, get some values of x from here. These are the values of x where maxima or minima will be existing, where maxima or minima will be existing, okay? Now it's not necessary that they will be existing there, okay, but there are chances. These are the equilibrium points. So when these are the equilibrium points, there are chances that either maxima or minima can be existing at those points. Now once you got those x values here, what you have to do, you need to find the second order derivative of potential, and you have to check out, let's say you got the values here as x1 and x2. So let's say you are going to check out at x1. If it is greater than 0, it means it's what? It means it's going to be greater than 0 means what? More people are supporting it. It's gonna have more votes, more favor, means it's the minima. Why minima? Minima means it's gonna be stable equilibrium point. Clear? Stable. Stable means the graph we will plot at that point should be something like this, because it's showing the minima here. Okay, that's how you have to consider it. If it will be maxima at the same time, this will be something you have to draw. So maxima, minima, whatever they will give you, that's how you have to consider it. Now next thing, let's talk about it. If in case you will get the same condition on x2 and you are going to get less than 0 on x2, so it means there the maxima is existing, and which means that's the unstable condition. Even here we are talking about the stability analysis separately, even I will explain that to you, but this is the main point. Even from the stability analysis section we are going to have, which we generally consider. Okay, now let's talk about the next thing here. So once you're gonna get these points, like the where the potential is 0, mark them in the graph. Once you're gonna know about the equilibrium points, mark them in the graph. A small dot you can just make there, okay, so that you will get to know what are the points where the maxima, minima are existing or all that. And then you can draw the trajectory or the v versus x graph first of all by following these steps. Okay, it provides you all the information. If you are not able to draw that v versus x graph directly, follow these steps and you can easily draw it. Once this step will get done, you are ready for the second step. And what is that? That is actually you just have to draw the energy lines. So draw energy lines. Now what are these energy lines? Actually, let's say you have drawn the v versus x graph, and let's say you got this graph something like, you can take anything here, let's say something like this. Okay, it can be anything. I'm randomly taking any of the graphs like this. So I want to draw the energy line now. So energy line is simply the lines parallel to the x-axis, and this is how we will be drawing it. So lines parallel to the x-axis is known as the energy line. And what these energy lines tells you, here at this point the potential energy and the total energy is equal. Here at this point also the total energy and the potential energy will be equal. Here at this point also it will be equal. Here at this point also it will be equal. So it will happen this way, that the points where the energy line is intersecting with the graph, the total energy and the potential energy will be remaining equal. Okay, so in that case what will happen? In this case we are going to consider, because our main target is to plot the p versus x graph. So at these points, wherever this will be intersecting the graph now in the v versus x graph, we have to take the momentum 0. We have to take the momentum 0 like this. So that's how we will be able to consider these different points. Let me know in case if you are gonna have any of the doubts here. Jay, I think there is no such final date declaration till now. Okay. So once it will get declared, then I will be able to tell you as well that when the exam will be. But till now we can just say that soon we can have the exam. So we should keep on doing the preparation, as much good preparation we can do, so that anytime if they will be declaring the date, the month or the time when we will have the CSIR NET exam, we will be ready for the exam itself. Okay. So once you will draw the energy lines, guys, now the third step you have to take is, wherever in your potential versus x graph the potential is increasing, you have to consider that momentum is decreasing, and wherever the potential is decreasing, the momentum is increasing. Wherever the potential is constant, the momentum will be constant as well. Okay, these are the relations we are going to consider. Until and unless it will get declared by the CSIR, like, or we are having any official information about it, I will not be able to tell you, but you can expect it that it will be soon. Okay, it will get conducted soon. Now if I'm going to talk about the fourth point here, guys, that's going to be that wherever the energy line is intersecting the v versus x graph, the momentum corresponding to those points in the momentum versus x graph will be 0. So wherever the E line intersects the v versus x graph, corresponding to that, what will happen? The momentum you have to take equal to 0. Okay, in the p versus x graph. And now why it's happening this way? Because we all know P is equal to root 2 ME minus V. So we are saying that wherever the energy line is intersecting the graph, the E and V are equal. So when they are equal, the E minus V will give us 0. So P will be equal to 0 as well. This is the point. Okay, I hope you are gonna get that. But in case if there is any doubt or difficulty, then you can mention it and we will be talking about it. Now, the fifth point is that wherever the momentum is positive, the direction of arrows in the final trajectory will be towards the positive x-axis. Okay, towards the positive x-axis. And wherever momentum is negative, the direction of arrows will be towards the negative x-axis. By keeping these things in mind, we can easily draw the trajectory anytime we want to draw the trajectory, means the phase space trajectory or P versus X graph. It will be easy for you to draw it anytime by keeping these points in mind. Let's talk about the next point now. What is that next point? That is actually about the second kind of or second type of questions if you will have, then what you will be doing. So let's talk about it. If any time some statement is given to you, okay, some statement is given to you, so it becomes very important at that point that we are gonna observe whether it is a conservative system it's gonna show us, or it is a non-conservative system. Whether it's conservative or it is non-conservative, it becomes very important for us to observe. If the system is conservative, means there is no energy loss. So in that case, the trajectories will be in such a way that they will not be intersecting with each other, and it's like the regular kind of trajectory, but they will not intersect with each other. Okay. At the same time, for non-conservative system, the trajectories will be like the connected curves. Okay, or connected trajectories you will get. So for the non-conservative system, where there is some energy loss, then at the same time, guys, if I'm going to talk about the non-conservative system, even in that case, no two trajectories will intersect with each other, same way like the conservative system we have talked about. Next thing here we need to consider is if there is any reason, okay, in the like graph we have plotted where the motion of the particle will be shown as the bounded motion. Okay, bounded motion. In that case, the trajectories will be the closed curve in the region wherever the particle is doing the bounded motion. So corresponding to that, the graph we will have to plot will be the closed curve. Okay, closed trajectories. It's very important point once again. So if you are getting to know about all these points which I have explained here till now, you are ready to work on any question related to the phase space trajectory whichever has been asked in the previous years, and you will not have any difficulty in solving any such type of question. So let me know in case if you are gonna have any doubt or any difficulty anywhere, we will be talking about it. And if everything is clear, that's great. So this is what you need to know. You can just observe all the points. After this, I'll be telling you about the stability analysis a little bit, and then we will be continuing the discussion about the questions. We will be solving different questions, and this is the discussion. Actually, if you get familiar with these points, you will not have any doubt or difficulty in solving any such type of questions in the exam. Clear? Okay, now let's consider the next point here, which is about the stability analysis. And also guys, I would like to tell you one more thing here, that is there are great chances that you will be able to get many questions from the section we are covering in these videos, like we are gonna cover up in these sessions. Okay, so many questions you can expect in your upcoming exam, because whatever topics I am considering in the sessions, from these topics there are many PYQs which are already available in the previous years. Those type of questions have already been asked, so it will be easy for you to relate with the PYQs, these concepts. You will easily be able to relate them, and wherever we will have some of the tricks, you will find like that's gonna make the things quite simple and easy for you, and it makes the things so much simple for you that in just few seconds you are able to excuse me, get the answer. Okay, now let's continue the discussion about the stability analysis. So in any such case, the potential will be given to you. For example, Vx is given to you, but there are some more cases we will be having, which I will keep on telling you one by one, step by step. Okay, that when you have to take some other potential and how you can construct or create some other potential here, and when you will not be using the given potential, when you have to use some different kind of potential. So I'll be explaining all these things here. So stability analysis we have to consider where the potential is given, done. In this case, again we just check out how stable a particle is or a position where we are going to consider the particle. So for that, what are the steps we take? We take the first step, which is about the equilibrium points. So dv by dx is equal to 0, which gives you the values of x, and let's say we got the two values x1 and x2. We can also get many other values, or we will just be getting the one value. That's okay. This is just an overview we are considering here about the type of steps we take to solve such type of questions. And once you will understand this part now, it will become quite simple and easy for you to consider or to know about it, that what steps you actually have to take, okay, there to solve such type of questions. So if I'm going to talk about the stability analysis, first of all, V will be given to you, means the potential will be given to you. The second thing is you will find the equilibrium points, means dv upon dx you will equate it with 0, and you will be getting the values of x from there, which can be x1 and x2. Okay, the next thing we have to consider is that we will have to check out now the second order derivative of potential at these points. What will happen this way? I can check it on x is equal to x1. I may be getting it greater than 0, but at the same time the second condition we can have is maybe at the second point or x2 we will be having this as less than 0. Greater than 0 means what? Greater than 0 means it's the stable equilibrium point, or we can call it the minima. At the same time, if I will be considering less than 0, I'm getting there, so it means it's unstable equilibrium point, and which means it's maxima. How you can understand this part? Look at this. If this is the type of graph you're gonna have, these points are maxima, this is minima, maxima, minima, maxima, minima, maxima, minima. Done. Next thing, if I'm gonna talk about the next thing here, if you will keep an object at this place, it can fall down, it can fall down while it is at the highest point, but again it can fall down. It's not stable, it's unstable, while the condition or that position may be considered as maxima, but it is unstable too, because if you will keep any object there, it can fall down. So in terms of life, if we are going to talk about it, in life most of the people want to be stable in their life and don't favor the unstable thing, means less than 0 votes for it when it is unstable condition, because fewer or somebody or maybe rarely anybody you will find who will support that unstable condition. So most of the people want to be stable in their life. If you will see, you are gonna have an object placed here at the lowest position, which is minima, and the object is stable. Why? Because it will not be going here or there or anywhere like that. So it means it's stable. Okay, when it is stable, it means that it's what? It is showing the minima condition. You can see from the graph, and most of the people support or wants to be stable in their life, so its value is greater than 0. So this is how you can easily memorize these conditions. Now from this section, from the stability analysis part, mainly we get the questions based on the angular frequency, which is simply root k by m, where k is the second order derivative of potential. Mostly we check it out on the stable equilibrium point, but whatever point they will ask you to find for, you will be writing the k as the second order derivative of potential at that particular point, and that's how you will be able to get your answer. But if they will ask you to find time period, that is 2 pi by omega. This is how you can relate it. I have told you one more thing, that we will not always be using the given potential in any such case. So we can also go for some other potential, which is generally known as the effective potential. But when we use the effective potential and when we will not be using the given potential, let's talk about that. So actually, if your system or the question statement is saying something about the circular orbit, Okay, or they have mentioned something about the angular momentum. So anything about the circular orbit or anything about the angular momentum has been mentioned there, okay, in the question. In that case, instead of using that given potential now, you will have to use the effective potential. The given potential will be there, but you will not be using it. You will be writing the effective potential, which is simply angular momentum square upon 2mr square plus vr. Done? Where this first term you just have to add in the given potential part, and that's how you are able to write the effective potential, and that's how you will be able to proceed further with this potential now, okay, to find anything you want to find. So you will not be using the given potential in any such case. You will go with this process, and that's how you will be able to get your answer. Let me know in case if there is any doubt anybody is gonna have till this point. If yes, you can mention it. If no, we will be taking some of the important questions here. While to consider some more points related to these points which we have considered here till now, okay, we will be taking more concepts after these points here in the sessions. But first of all, let's take the questions based on these ones right now, and after completing them, after solving those questions, then we will go for the other ones. Just give me a second and tell me in case if there is any doubt, you can mention that. Two particles of identical mass move in circular orbits under a central potential excuse me, this is R1 upon R2, okay. Just try to solve it now and let me know if you're gonna get whatever option will be the correct one according to you. Just check it out. If you're gonna get the right answer, mention it in the comments. I will consider it then. I'll be waiting for your answer for just some time and then I'm gonna explain it too. See, the hints are they are talking about the circular orbit. Okay, they are talking about the central potential. So we have talked about these points, that circular orbit or angular momentum, and even they are talking about the angular momentum. So can we use the given potential? The answer is no. So we have to go for the effective potential. Yes, that's gonna be L square upon 2mr square, because they have shown the angular momentum with L. So I have to show it with the same notation, plus half kr square. They have given us the L1 L2 ratio and they want us to find the R1 R2 ratio. So the best thing is, let me just get the dependency of L on R, and that's how, if I will get it, I'll be able to use that condition to get the ratio. So for that, I'll be getting delta V effective upon delta R and equated with 0, so which will give you minus L square upon, that's gonna be 2. Here we will have minus 2 and minus 1, which will give us 2mr cube. Then we will have plus kr, and that will be equal to 0. So L square, you will keep it this side, kr you will shift on the other side, you will get L is proportional to R square. So which will give you what? L1 upon L2 is equal to R1 square upon R2 square. So R1 upon R2 will be square root of L1 upon L2, which will give you root 2, which is going to give you option A as the correct option. You can see how easily you are able to get that answer. In case still if you are going to have any doubt, you can mention it and we will try to consider that point as well. Let's take the next question. If anybody will have any doubt, you can surely mention it here and we will talk about that. Next question. Neglect friction. Try it now and let me know as you will get it done. Whatever will be the right answer according to you, just mention it, and mention that as your right answer in the comments. If you will not be getting it, I will tell you that how you will proceed further or what are the steps you have to take to solve this type of question. Sometimes to solve the questions we just need to use the basic information. We should have some basic idea about the system or the expressions. So if we are having that, we can easily relate the things with the basics and we can get the answer. But if we don't know about those basic expressions, the formulae, or we can't relate them here with the question, so then it can be quite difficult for us. Try. If anybody is gonna get the answer, just mention it. If you will not be getting the answer, then that's okay, I'll be discussing it then. So it has been given the trajectory on the ZPZ plane of a ball bouncing perfectly elastically off a hard surface at z is equal to 0 is given by. So surface has been taken at z is equal to 0. In that case, what will happen? In that case, above that, the positive values we will only be having the positive value of z, because the ball will not go under the ground, it will just stay up. So which means in the positive value of z only we have to take the motion or the movement. In that case, if we are going to talk about the potential for any such case, it's simply in the form mgz or mgh we can write. Here, to draw the graph between b and z, what we will get, it is y is equal to mx form, which is the line, straight line passing through the origin. Okay, and in this case, hello Tony. So in this case, what will happen? It's gonna be v versus z graph we have got. Now we have to draw the energy lines. When we are drawing the energy lines, what will happen in that case? We will be considering that the points where the energy lines are intersecting with the graph, at those points the momentum will be 0. And also we know wherever the potential is increasing means what? If you are going to increase the z value, the corresponding potential will also be increasing. That means the increase. Okay, if you are increasing the z value and the potential is decreasing, that means the potential is decreasing there. So once it's increasing, the momentum should decrease. You can see this condition that if you will take this value of z here on the top, you are having higher momentum, but as you keep on increasing the z value, the momentum decreases. So that's how you can consider it, that this part is showing us the right phenomena as per the condition we are having. And one more thing, that it should only be in the positive z direction or positive z case. So that's option A, which is giving us the more correct option or the answer for this question, and that's how it's our right answer. In case if you're gonna have any doubt anywhere still, you can just mention it and let me know about it. But if you're gonna get it, that's great. This is how you will be able to get the answer for any such type of questions. Let me just give you the next one now. In case still if you will have any doubt or difficulty, then you can mention it and we will talk about that. The next question is, the bob of a simple pendulum which undergoes small oscillation is immersed in water. Which of the following figures best represent the phase space diagram for the pendulum? Options are P Z P Z it's actually X they have taken, but that's okay, we can take either X or Z here. The next one is, it's just a circle, closed circle. P, either take X or Z, anything. Try to solve it now, and whatever is the right answer according to you, just mention it in the comments. We will be considering it. So the bob of a simple pendulum which undergoes small oscillations is immersed in water. Okay, energy loss will be there or not, you can consider that part. Conservative system or non-conservative system, you can consider it this way. Which of the following figures best represents the phase space diagram for the pendulum? So you know, if it is non-conservative system, the trajectory should be connected curves. We have talked about it. Only two options are there, that's B or D option can be correct. So in this case, what will happen? In this case, we will have to now check it out that which one is showing the right phenomena. Option B is showing that it will keep on increasing. The arrows in the outward direction means keeps on increasing. So you can consider the phenomena that when you are just gonna put the pendulum, which is doing some motion, oscillating in the water, will its oscillations or the distance covered will increase or will it decrease? So it will decrease. So which means in option D, if you are just going to check it out, you can see the arrow is inward, means it's just decreasing there. So option D will be the correct one this way. So let me know in this case if there is any doubt anybody is going to have. If everything is clear, that's great. But if there is any doubt, you can mention it or let me know about it. Clear? So that's how you will be considering this part. Let me just give you the next question. And it's related to our previous class discussion, which was about the Hamiltonian and the conserved quantity. So it's here. A system is by the Hamiltonian which is going to be px minus ay square plus half py minus bx square, where a and b are constants and px and py are momenta conjugate to x and y respectively, for what value values of a and b will the quantities px minus 3y and py minus 3x, no, py plus 2x be conserved. Just a second. Py plus 2x be conserved. Options are a is equal to minus 3 and b is equal to 2, or A is equal to 3 and B is equal to minus 2, A is equal to 2 and B is equal to minus 3, A is equal to minus 2 and B is equal to 3. Now let me know once you will get it done, what should be the right option according to you. If you're gonna get it, if you're not getting it, then I'll be talking about that, but if you're gonna get it, that's great. Hello Bharat, just check it out once. Which one is the right option? And the condition, you know, if there is a conserved quantity, so its Poisson bracket with the Hamiltonian will be what? It will be 0. So you just have to take the Poisson bracket of the given Hamiltonian with 0, okay, for the given function, Poisson bracket of the given function. For example, once you are going to consider the function as px minus 3y, so its Poisson bracket with the Hamiltonian you have to take. At the same time, py plus 2x, if you are going to consider its Poisson bracket with the Hamiltonian you have to take. And once you're going to do it this way, then you will be able to get the A and B values with this process. So if I'm going to consider it, very good Bharat. So it's going to be px minus 3y, first of all I'm going to consider as a first function. Okay, and the Hamiltonian is given as half px minus ay square. Then we are going to have plus half py minus bx square. Clear? And we have to take it 0. This is the Poisson bracket we are considering. First one, partial differentiation with respect to x 0. Second one, with respect to px, will give us just px minus ay. But actually we don't need to write it, because when the first term is 0, 0 into anything will be 0. Minus first one with respect to px is 1. Second one with respect to x will be py minus bx into minus b, which will make it plus b. Okay, that's how you will be able to get it. And into 1, that doesn't matter. And then plus sign, first one with respect to y you have to differentiate, and second one with respect to py, that will simply be giving you 1, minus first one with respect to py 0. So this is what we are going to get. So it's going to give us py, b common, py minus bx. And one more thing guys, we have here taken the first one with respect to y and second one with respect to py, so we will be getting py minus bx here as well, okay, at this place along with minus 3. So minus 3 py minus bx, and that's gonna be equal to 0. Let's take it common, py minus bx, let's take it common. Inside the bracket we will just have b minus 3 is equal to 0. If you will equate it with 0, you will get b is equal to 3. Same way, if you will take the second function and you will be taking its Poisson bracket with the given Hamiltonian, you will get it 0 as well. So that's how you will be able to get your answer quickly. And you can also see, once I have got the b value that is equal to 3, only in one of the options given there we are having b is equal to 3 present in option D, and that means the option D will be the correct one. In case still if there is any doubt anybody is gonna have, you can just mention it. We will talk about that, and if everything is clear, then that's great. So let me know in case if there is any doubt anybody is gonna have. Let me just take the next question now. Okay, same process for the second function you can also do, and you will be getting the a value as well. While since our answer is matching with only one option, so we are ready to answer it just like this as well. Next question. Next question is, a particle of mass m and coordinate q has the Lagrangian that's gonna be L is equal to half m q dot square minus lambda upon 2 q dot square. Now you can see one more thing, that by just discussing some of the points from classical mechanics which we have covered in just the last session and today this session, So how many questions we are finding in the previous years based on that discussion? Even there are many other questions, we are just taking some of them right now. So you can see it's covering the great section from our previous years, and which means everything we are talking about, we have talked about till now, is very much important. P square upon 2m square. Try it now and you can solve it just in few seconds. But how, we'll be talking about it if you don't know, and if you know, you can answer it too. Hello Ria. Check. Let me know as you will get it done. Very good Bharat, very good Ria. Okay guys, now even let me just tell you how in just few seconds you will be able to get its answer. We have talked about a trick in the last session that if we are able to relate the kinetic and the potential energy terms separately in the given Lagrangian or in the given Hamiltonian, then we can do the conversion of that Lagrangian or Hamiltonian in the other one. For example, Lagrangian is given and you want to write the Hamiltonian, then with the help of trick you can do that. Or if the Hamiltonian is given and you want to write the Lagrangian with it, okay, then you will be able to do that too. But how? Let's talk about it. So here we can see that Lagrangian is given. I'm gonna take the half common and I will be getting m minus lambda q inside the bracket and q dot plus the minus 0 actually, because it will become T minus V form. So maybe the potential energy is 0, so kinetic energy is matching with the form half mv square. At place of m, I'm gonna get m minus lambda q, okay, which means what? Which means we are going to consider the Hamiltonian now, which will be p square upon 2m. So p square upon 2m means what? M minus lambda q, and then plus potential energy, which is 0. P square upon 2m minus lambda q, it's there in option B, and that's our right answer. So you can see in just seconds, if I am able to separately get this term for kinetic and the potential energy, then I can get the value for the Hamiltonian easily this way. In case if you are still having any doubt or difficulty in solving it, just mention that, I'll be talking about it, and if you are now going to get it, that's great. We can talk about the next question now. If there is any doubt or difficulty, you can mention that too. Otherwise, let's go for the next question discussion. Let me just give you the next one now. There are actually so many questions from these topics, so many, not just one or two. or not just few but many. So depends which one you want to solve, which one like you want to do. Even after this session you can check out the previous year questions later on, and related to the discussion which I have done just in the 2 sessions, you will be finding many questions there in the previous years. One question which is based on the trick I'm going to take now. If you know the trick, that's great. If you don't know, I will tell you. So it is also a previous year question we are going to have. A particle in 2 dimensions is in a potential Vxy is equal to x plus 2y, and which of the following apart from the total energy of the particle, okay, apart from the total energy of the particle, is also a conserved quantity or constant of motion. It's based on a trick. If you know that, you can answer it quickly in seconds. If you don't know, you can go with the detailed method too. Okay, you are having both the choices. Px minus 2py, px plus 2py, then it's gonna be py. Oh, the first one is also having py in it. Correct, px. Just check it out and let me know which one will be the right answer according to you, if you're gonna get it. If you're not getting it, that's okay, I'll be telling you, but if you are going to get it, that's great. Check. What will be your right answer here if you know that? I'll be telling you just in few seconds then how you can work on this question or what actually is the trick. Okay, so basically whenever you will have the potential expression given to you in terms of x and y, like you can see it's given right now, and you want to know about the like momentum in terms of linear momentum, what will be the conserved quantity. So for that, what we do, if our potential is in the form ax plus by, then in that case we write the linear momentum corresponding to the different components this way. We just have to interchange the coefficients this way. We also need to change the sign, like positive is here, then you will take the negative here. If positive, you are making that sign change, you will keep it same. If you are changing this sign, then you will keep the other one same. So this is how you got 2 quantities. In our question, at place of A we are having 1, at place of B we are having 2. So B is 2, A is 1, B is 2, A is 1. So in this case, you can see either you will have the 2px minus py. Is this present somewhere? No. You can check it out. With the px, there is no 2 present in any case. Okay. So in that case, what will happen? You will be writing it this way. That's gonna be minus 2px plus py. So where it is? Option A. Only one option is correct here. Bharat, only one option is correct, not D. You can see that either 2px minus py or py minus 2px. So the only option which is matching is option A. That's how you are gonna get that. In case still if there is any doubt anybody is gonna have, let me know. Otherwise, this is the trick. Or the other thing you can do here is to find the Poisson bracket of the options one by one. For example, option A with the Hamiltonian, what will be the Hamiltonian? That will be p square upon 2m plus the given potential energy. So by checking the options Poisson bracket with the given potential associated Hamiltonian, if you will get it 0, that means it's the conserved quantity or constant of motion, otherwise no. So that's how you can even check out with the detailed method. It depends like which one you find more beneficial and more easy to consider in the exam, you can go for that. Let me just give you the next question now. let's take this one. Undergoing small oscillation. Whatever answer will be correct according to you, you can mention it in the comments. If you're not gonna get it, I'll be discussing it then, don't worry, but you know the complete process to solve it, so I think everybody can do it easily. Try to solve it and let me know what will be your final answer for this question. Okay, once again, let me just tell you what are the steps you can take and how you can solve this type of question. So actually the time period of the particle of mass m undergoing this small oscillation around x is equal to 0 you need to find, for which the potential is given to you. So time period t is equal to, we all know, that's going to be 2 pi by omega, and omega is equal to simply root k by m, where k is the second order derivative of potential. So when you will differentiate it once, it will become sine hyperbolic with a negative sign, or just simply sine hyperbolic, okay, and 1 upon L will remain there outside. Then it will become what? It will become cos hyperbolic once again after the second order derivative, but 1 upon L once again it will be there. So V0 upon L square cos hyperbolic x by L we will get after taking the second order derivative of potential. Now we want to find the time period at around x is equal to 0. So if I will put x is equal to 0 for the cos hyperbolic part, I will be getting cos hyperbolic 0, which is 1. So V0 by L square we will be having there, which will give us simply V0 by ml square inside the square root, and 2 pi will remain there. So V0 will remain in the denominator part, as we are getting that as the omega value. So option C will be the correct one. You can see how simply and easily you can get it done. Omega is equal to root k by m, where k is the second order derivative of potential, and that's how easily you will be able to get your answer too. But in case if you're gonna have any doubt, you can mention it, but if it's getting clear, that's great. We can consider the next point now. I think I have talked about the total time derivative part as well. If no, I'm going to tell you once again. For any function, if you want to find the total time derivative, which is dA by dt, where a is a function, it will be equal to the Poisson bracket of a with h plus delta a upon delta t, which is the partial differentiation. Okay, so in this case, if any time you have to find the total time derivative for any given function, you can use this formula and you will be able to get your answer for that. Now I'll be giving you the question related to this part as well. Just check it out whether you are able to get it or not. If there will be any doubt or difficulty, I'll talk about it then, but if you will get it, that's great. the Hamiltonian Try it now and let me know, as you will get it done. And which option is correct according to you, you can just mention that as well. Whatever option you are finding, like, oh, this will be correct one or that will be correct one. Try to solve it and let me know which one is the right option. So you have to find the total time derivative of the dynamical variable, which is p plus root 2x here. In that case, what we will do, we have to find its Poisson bracket with the Hamiltonian, and we have to equate it with 0. So it's gonna be half p square plus x square, and you just have to equate it with 0. So what it will give you, first function partial differentiation with respect to x, that will be root 2. Second one with respect to p, that will be p minus first one with respect to p1, second one with respect to x, that's x is equal to basically we are not finding that it is conserved quantity or not, so we are just writing the formula for dA by dt, which is Poisson bracket of a with h, where a was the function, plus delta a upon delta t. So this will be our answer here, which is this, and delta a upon delta t will be 0. Reason behind it, it's not dependent on time, or the t term is actually not present there, so partial differentiation part will be giving us 0. Okay, in case if you're gonna have any doubt, you can let me know about it, and if it's clear, then that's great. Done. Let's take the next one now. One more question. xp square upon 2m plus half kx, where m and k are the positive constants the corresponding Euler-Lagrange's equation for the system is, options are mx double dot plus k is equal to 0, mx double dot plus 2x dot plus kx square is equal to 0. Next one is 2mx x double dot minus mx dot square plus kx square is equal to 0, and option D is mx x double dot minus plus 2mx dot square plus kx square is equal to 0. You can try it. If you will not be getting it, I'll tell you what are the steps you have to take and how you will be getting the final answer. But if you will get it, that's great. And if you're gonna get it now, just mention it in the comments that which one is the right option according to you. Otherwise, just in some time I will be starting the discussion too. See, the Hamiltonian is given and you want to find the Euler-Lagrange's equation. Means the Lagrange's equation of motion, which is d by dt delta L upon delta Q dot minus delta L upon delta Q is equal to 0. But the first thing we have to do is to do the conversion from Hamiltonian to Lagrangian. You can easily compare the Hamiltonian form with the T plus V, that is kinetic energy plus potential energy. If you will be comparing it with that, the kinetic energy term will give you P square upon 2m form, where m you will get as m upon x. If you will take that x in the denominator once again, it will go in the denominator of x. You can write it in that form too. And plus potential energy, so potential energy is half kx. Now if I want to write the Lagrangian with that, I can write it as half m is m upon x, v square, which is x dot square, minus half kx. This is the trick which helps us to write the Lagrangian with the given Hamiltonian quickly and easily, and that's how you can convert it. At the same time, now when you want to find the equation of motion, you have to just use it. D by dt delta L upon delta x dot minus delta L upon delta x is equal to 0. If I'm going to consider delta L upon delta x dot, you have to just differentiate this x dot square term. It will give you 2x dot, 2 cancelled out, mx dot upon x will be remaining there. So you will differentiate it once again. So mx dot upon x was there. Now when you will differentiate with respect to time, you have to use the quotient rule. So m will remain as it is, and delta L upon delta x dot, what it has given you, x dot upon x. Now use the quotient rule there, which is denominator square, the denominator as it is, numerator differentiation, minus numerator as it is, denominator differentiation, which will give you x dot square this way, minus delta L upon delta x. It will differentiate the both terms because x is here as well, which will give you minus plus half m upon x square, x dot square. Okay, at the same time we will be getting the plus, okay, that's gonna be half k is equal to 0. Now you have to take the LCM of x square, so remove it from the denominator, it will come here. Also remove the 2 from the denominator, which will come here. So this is how you are getting 2mx x double dot, 2mx x double dot, where it is, it's here, and that's how your option C will be the correct one. You can just check it out, and that's how you're getting your final answer. In case if there is any doubt anybody is gonna have, just mention it, and if it's clear, that's great. So let me know if there is anything which is not clear to you, or anywhere you are gonna have any doubt. We will talk about it, and if it's clear, we will be just keeping it this much right now in the session, guys. Thank you so much everyone for joining the session. As I've told you in the starting of the session as well, that if you want to attend the more regular live classes of well structured and well planned courses by the top educators, in that case you can take the Unacademy Plus or the Iconic subscription. And guys, whenever you will proceed further to take the subscription, you can use and apply the referral code, that's Anjali A Live, as mentioned here on the screen. So by using and by applying this referral code, you will be able to get the 10% discount in the total subscription amount as well. So thank you everyone for joining this session. And even in upcoming days, many new courses by the top educators will be starting on Unacademy. So if you don't want to miss them and you want to attend the regular live classes, then you can take the Unacademy Plus or the Iconic subscription and start your preparation under the guidance of top educators. Even you can have a look at this UA Lite subscription.